Now we have a swap of a training room, so our guest is, I don't dare to pronounce your name, is to
Hrnjadovic.
Okay, thanks for that. The name that I want to pronounce, which is Rackspace, that is your company.
Yes.
And for the ones who don't know about Rackspace, I think is...
That is me, yes, sorry.
Okay, it's fine. Rackspace is like a relatively tiny competitor facing colossus like Amazon in the cloud business. How can they do that? Well, probably they are really pro. They are daring, brave in that phase, and they are using a lot of open source instead of their other competitors who are much more closed. Mm-hmm. So, can you tell something about Rackspace as a company and as an employee? So, how do you feel working in Rackspace? Your open culture and so on.
Okay. So, I have a mic here. Okay, so good afternoon and welcome to our OpenStack training. I'm very happy to see you. You came in large numbers, which is good. So OpenStack is a project that will turn 3 years on July 19. So it's a very young project still. It's an open source project, and it was established. OpenStack was founded jointly by NASA and by Rackspace almost 2 years ago. So. Like by way of project history, so NASA, what NASA brought to the table was the Nova component, which is the equivalent of Amazon's compute service, and Rackspace brought the Swift, the object storage component, into the project. Okay, so shortly after the project was established or founded, NASA withdrew from it though. So this is just not part of what they want to do. So NASA is about about research in space, etc., etc. So they said, look, we are NASA. It's not part of our mission to build an open source cloud. And so Rackspace was left with OpenStack on its hands. Okay, had all the goodies for itself, all the toys, and decided that this is not a good. This is actually not a good situation to be in. So Rackspace didn't want to play with itself. And what we did instead is we established a foundation, the OpenStack Foundation. And all of the OpenStack project, all of the intellectual property was transferred to the foundation. And the foundation, the governance structure of the foundation was designed so that, that other companies could join or other players could join and engage in the project, at the same level as the project founders. Okay. So shortly after the foundation was established, many companies joined, like Red Hat, IBM, HP, etc., etc. And now we have quite a coalition. If you look at the companies who are part of the foundation, it reads a bit like the who's who of IT, with some notable exceptions. Okay. And that's quite a success. It's quite a feat. I mean, to form such a foundation, such a coalition of IT companies, and also to unleash such an open source project within a short period of time of only 3 years.
So the bottom line is you can go open and not to regret it.
No, because as I said, when I joined Rackspace 8 months ago, I was talking to certain people, and I said, look. This foundation, this project, basically allows us to push the envelope in cloud computing. I mean, because this is a great example of companies who compete otherwise collaborating inside the confines of an open source project, and as such, it is very much reminiscent of the Linux project. And as I said, when IBM announced that they want to base all of their cloud products on OpenStack, this is the comparison they drew. They said, from our perspective, OpenStack is the Linux of the cloud. Okay, so this is the project as it stands today.
Not so bad, I say. If you want to spend a few more words, more about focus on yourself. So why did you choose Python as a language, favorite language? Can you say? Okay. And what you are going to talk about to us?
Yes. Okay, so I sort of started looking at Python and Ruby like 7 years ago, and I had no I had no preconceived notions on either language. But then, sort of, I was turned away by Python because of the white space thingy. I just thought this is stupid. Okay, and then I looked at Ruby, and Ruby looked too much like Perl. I said, no, I can't use this language. So I swung back to Python, and like after half a day, the white space just made a lot of sense. I said, yeah, this is actually cool, and I started using it, and the more I use it, the more I loved it, and I just enjoyed it. I enjoyed writing code in Python. So this is the beginning of my journey into Python. So, like I've been working in in open source projects since 2008. Okay, and so when this opportunity came along to join Rackspace and become part of the OpenStack movement project, I gladly jumped on it, and today I stand here in front of you. And hopefully we can sort of spend a great afternoon together and dig into this thing. Okay.
Okay. A few more rules. This afternoon we'll be always with one REM.
Actually, I have cohorts. I have helpers who will help me with certain aspects. So I have Joe Gordon. Is Joe here? Okay. So Joe is working with HP at this point. He's a core contributor to the Nova project. Oh. And he will cover the Nova part. And I have Shmuel. He stepped out for a second. Okay. So the two main components of the cloud we'll cover today are Nova, which is the compute service, and Swift, which is the object storage service. Okay. So Joe will cover Nova, and Shmuel will cover Swift. And both gentlemen are co-contributors in this respective area. So you're very competent people who will basically teach you the stuff. So I'll give a quick intro, and I will once they finish, I will just quickly cover some cloud architecture aspects, like more generally, like what should be the structure or architecture of a system you want to deploy in the cloud. So that's it.
Okay. One last thing: if anyone has to ask a question, you should just raise your hand. Then I will come and bring you the mic. This room is not huge, but without the mic, we risk that someone else can't listen to you. So it risks to be just a bit one-sided. Not to mention that your questions are going to be streaming as all this lesson as well. So don't fear to bother us. My legs are strong enough. I will come and bring you the mic every time it is needed. Okay?
Okay. So question number one is like who managed to come into the kickoff session this morning about the OpenStack kickoff? Okay. Cool. So because we plan sort of to dive straight in, so I will really maybe just talk about the general makeup of the OpenStack project for maybe a couple of minutes, and then Joe will start this part. Okay, so OpenStack, it's an open source cloud project, and it was built to be scalable, to run on many machines. Okay, it was built as a distributed system from the outset, and all the OpenStack components, which you can see on the slide here, okay, basically talk to each other. If they need to have interactions, all these interactions are asynchronous. A message broker, an AMQP message broker, is used inside the system. And again, so the idea was that this system would run on hundreds of thousands of machines and be able to operate huge clouds. So Rackspace also happens to be the biggest public OpenStack cloud provider today, and we certainly operate. I'm not really allowed to say, but we certainly operate like tens of thousands of machines in our public cloud, and so this software was built that way. Okay, so the components we will focus on today are Nova, which is the code name for the compute component. Okay, and so Joe will take you through everything that Nova can do, and so to the most important operations, and Swift, which is the object storage on the right hand side. Okay, so if you ever use the Amazon cloud, so Nova is similar to EC2, and Swift is similar to S3, the simple storage system they have. Okay, so do you have any questions of general nature that you will ask at this point, or should we go straight into it? Okay, so Joe, if you could come to the front then. Do you have an adapter? Ah, okay, that's cool. Okay, so maybe if you want to say a couple of words and introduce yourself.
Yeah. So today we're going to talk about Nova and for you guys how to use Nova itself, and that's how to use the Python Nova client, which is the bindings. It's Python bindings and the CLI for Nova itself. So just a disclaimer here, we thought there would be a few less people here. We have access to a public cloud thanks to Inovant and Shmuel, but there's not enough space for everybody on there, so we may have to improvise a little later. So about me, I'm an OpenStack developer at HP, and I've been working on it for about 1.5 to 2 years, and I'm part of Nova Core. So unfortunately, the rendering here is a bit rough. You can't see the bottom of the screen here, but this is what the OpenStack architecture looks like overall. So it's there's lots of pieces, the dashboard, compute, image storage, network, and we're going to talk about how to use compute itself. And on the bottom there is authentication that you can't see. So we're going to talk about Nova. This is the actual Nova architecture itself. And we're not going to dive into actually how Nova works today, but we're going to talk about how to use it. There's a lot of pieces to it. There's the API server, which you guys will interface with. There's the Nova compute service, which actually runs on each compute node. So that actually will be running KVM or Zen or whatever it is. There's stuff for console and VNC. There's the database, the message queue. Nova Conductor, Nova Scheduler are both internal services. Scheduling and such. So what does Nova actually do? From the REST point of view, there's a lot more to it than this actually, but this is, from a consumer of Nova, this is what it does. So there's a lot here that is not listed, and there's those admin APIs. That's for, if somebody's deploying OpenStack and Nova, they need to do a whole bunch of things that you guys probably won't see. But for a user, it allows you to manage instances, create an instance, pause an instance, shut it down, snapshot, etc. Allows you to assign an IP address, a public or a private address, or a static or fixed, static or floating. It allows you to manage key pairs for your instances, so you can log in with a key pair and not a password. It allows you to assign network, so this is for VPC kind of a system. So you want to have a bunch of machines on a network together. It allows you to take snapshots of your instances. You can boot from a snapshot, restore from that, etc. And this is the basic commands you could do with OpenStack and Nova. And so it looks very simple here, but there's a lot more to it, and there's a lot of nuance and subtleties and permutations of this. So this is the Python Nova client. So if you guys want to do something in your local machine, it's on GitHub and on pip. So you just pip install Python Nova client. And as we said, it's the CLI in the Python library. So hopefully this will work. This actually will only work for 15 of you, which turns out there's a bit more than 15 people here, so you may have to pair up. So one of the things, Nova has a lot of, OpenStack itself has a lot of controls for the deployer to limit the system. There's a billing system that's not mentioned here. It's outside of Nova. But there's also a concept of quotas. And so if you're a deployer, you want to say, you don't want to allow every user to spin up 1,000 VMs because, well, you don't have the capacity or you don't trust them or you don't think they can pay the bill. So in this case, we actually have Inovant to set up the quota of 15 instances for our test user. So we can only spin up 15 VMs. But I guess more of you should be able to actually interact with it, and we're all going to share the same user since this is just a demo. So this is actually a VM running on the Inovant's cloud, so you should be able to log into it. That's the username and password and the IP address. And so we're going to use that to do the development on. So when you get into there, Python Nova client's already pre-installed, and you can go ahead and make yourself a directory in the home directory and be nice to each other. Don't step on each other. It's an M1 tiny. We didn't expect this many people, so hopefully it won't be too slow for everybody. So I'll give everybody a minute to get in.
So create a directory per user, right?
Yes.
So your name in the home directory?
Whatever you want. This is a VM is ephemeral. We're going to delete it right after, so you can do whatever you want to it. In theory, everybody has sudo access. Please don't use it. You can't really do any harm except to each other. So. A lot of users logged in. So we're actually going to only be able to spin up 15 VMs at a time. So that means if everybody does all these commands at once, we'll have problems. But you could actually do other commands and interact with the system without spinning up a VM necessarily. And so we'll have to coordinate about who's spinning up what VM. And you'll see actually quota errors, hopefully, if everything went well. So we should actually see the quotas working from this. I'm not doing anything. I'm just making sure everybody's into the system, that's all.
So you guys just watch it all?
Yeah. There's 40-something users on here right now, so that's all I'm doing.
They can share that with us.
What?
I mean, I want to see what commands they have.
Yeah, I could put, well, you'll see in a second. I have some, the next slides will show that. I'm just waiting for everybody to get in. So I have some sample, these are, you'll see, some sample slides coming up.
Yeah.
So that's what we're going to base this all on. So once again, I'd like to thank Inovant for setting this up for us. It's very generous to them. Thank you, Shmuel, on the back. So thanks to him, we have this nice cloud to destroy. So is everybody mostly into the system? OK. So we're going to use this just because it's easier than, presumably everybody here has a working version of pip, but Ubuntu doesn't always have pip working. And so we just figured it'd be easier just to have a box everybody could play around on and a VM for that. So now that everybody's in, we're just going to go over some basic things here. So, whoops. So booting a VM. The basic things we're going to try to do today is we're going to try to boot a VM, and we're going to log into it, and then we're going to destroy it. Nothing too crazy, although if you guys have time, which I think we will, you probably could go and play around with some more things. And so booting a VM, there's a bit more to it, and you have to add a key pair so you can log in, find out what instance type you want to create, et cetera, and we'll go through that too. So this is the CLI. So actually, this image doesn't exist on this system, but this is a sample. So this is how you boot with the CLI, which is there. If you type in Nova onto the system, it'll just show up. You should see a help message. So Nova boot, the debug flag's on just for testing. Nova boot, flavor, image, key name, instance name. And so that's a basic command, and we're going to do the same thing in the Python library itself, and it's a bit bigger, as you can see. A bunch of this is, and we're going to go through what this all means. So actually what you guys could do already is type in Nova list on your system. And I want to show you there's actually instance running on here, which is your instance you're all on. So anybody could delete that, so please don't delete it. Otherwise, you're all going to kill yourselves. So beware. Sorry, I forgot there's one step first. We have that OpenRC file in your home directory. So the first thing you want to do is you want to source that. And this is the credentials. You can actually cat it. So this is the credentials, and you could actually, this is the information you need to get into the system. So your username, your tenant, password, and then the auth URL, which is the Keystone service.
Maybe you can explain what the tenant is.
Yeah. So I can't see it here, unfortunately. But the tenant is, so there's usernames, and a tenant's another name for a project. So there'd be multiple users could have, a user may be part of several different projects or tenants. And so you could, the quotas are applied, could be applied per project. So you say, these users are all in this project, and they could share information, they could share VMs. And so it's a way of it's a working group. So we're all one tenant here, and in this case, we're all one user. But if this is a real system, we would have different usernames and all one tenant. And so that information is shared in the compute, image, and all the storage in the network system, so that the username and tenant information is passed around, so it works for the whole system. Is there a cable I could steal to get faster internet? Anybody? Because the Wi-Fi here is terrible, as you guys know. There we go.
Are you comfortable? Not so much.
Yeah, I can move this over. So this is what I want to show you guys. So Nova list, and this is our box, dev box. You can see that's the name of it. So please don't destroy this VM. If you do Nova or delete dev box, it'll delete it.
Does it work? Maybe you have it to rotate. We have it to rotate a bit. No. You
Okay.
I rotate the camera.
It's the deal. Okay.
Here is okay. It works. The connection works.
Yeah, it's great.
Okay.
Yeah.
We have to call that creation of that machine.
No, you don't. I'm just showing you that this is the machine they were all using. So I went ahead and before this, and I logged into the system, and I created an instance for everybody to use. And that's the development box we're using right now. So we'll get back to that in a second. So the anatomy of a boot command. So this is that same command that we showed before. And then there's a few steps. The first step is you get a token. So we have a username and password. And the system internally uses a token to confirm who the user is. And so the first thing we do is we talk to Keystone and we get a token back. So we tell Keystone this is our username, this is our credentials, and it goes, here's a token to talk to the rest of the system. Now we have this image name, but that's not how Nova actually recognizes images. So you have to look up the image name. So you take the image name, you look for the ID that you need to use to actually pass into the boot command. And the same thing for the flavor over here, M1 tiny. That's also the name that a human would use and not the system would use. So you're also looking up the flavor name on the system. And finally, we have all the information we need. We have the image, the flavor, and our token. Now we can actually talk to Nova again and tell it to boot the system. We send a post command.
Maybe if you wrote your console to the front and did like Nova flavor list.
Yeah, we'll do that.
If you show these commands, it will make things easier.
Yeah, I'll do that. Sorry, 1 second. So we source the first, this is that file we showed, so this is the username, tenant, password, and the URL. Actually, let me try to take one step back here. So there's actually another thing here, which is the dashboard. And if this all works, we can actually see it. So I see 3 of you already went and created an instance, which is good for you, and we'll get to do that for the rest of the people in a minute. So this is our quota here. So we have 4 instances, 20 CPUs, a bunch of RAM, et cetera. And we can see somebody, here's their instance over here. And so we'll get to how, this is another way for you to interact with the system. In this case, we're actually going to focus on just the CLI and the Python client. So we type in Nova, we get this big message here. And these are all the commands we have. So some limits, some administration tools for the admin, some assorted other tools that we're not going to focus on today.
Can you just increase the font size?
Yeah. So some commands for the IP, floating IPs, fixed IPs, flavors, images are here too, etc. And so we're going to focus on a small subset of these commands today. So the first thing we can do is you can actually see the flavor list here. And let's make this bigger. So here's our different flavor options. So we're all going to focus on either M1 small or M1 tiny because they have one virtual CPU and we only have space for 20 virtual CPUs. So we don't want to do, if two people do extra larges, then we're sort of done. So this is all configurable by the admin. So there's actually commands, Nova client commands to actually control all these. But we don't have access to do that. And that's all blocked for regular user. That's admin only. The second part we need to know is the image list. So what kind of image are we booting up? And we see we have a bunch of options here, and you can pick anything you want. Although I'm not sure if the Windows one will work for us. I don't know if there's any extra stuff. I haven't tried that yet. But we have the basics, Debian, Fedora, Red Hat. And there's also commands in Glance to load your own images. So Glance is the image service. And this command actually, although it's a Nova command, it's actually going to Glance underneath. So now we're going to walk through these basic commands over here and actually how to talk to the system using Python. So the first thing is you need to source your RC file here. So hopefully a bunch of you already done that. And then this is to actually talk to the system. We have to import Nova client. And so we're going to use the, this is cut off. There we go. So this is the basic command to actually authenticate to the system. So what this command, this block of code will do is it'll talk to Keystone, get a token. So the first thing here is we import OS and Nova client. I guess I don't need OS here, but we import the Nova client. So we're using the V1 1.1 version of Nova client. It's the only version there. You don't need to actually import version 1.1, but we're going to just do it for now. And we want to get their credentials, so we're just getting them from the environment. So we already sourced that RC file. That just makes things easier in our situation. So we're importing the username, password, auth URL, tenant, etc. And so the first thing we're going to do is we create a client. So create a client and pass in the credentials. And then we'll run Nova authenticate. And that'll actually talk to the system, talk to Keystone, get a token back. So if you have the wrong configuration there, if you pass in a bad password, that'll actually throw an error on you. So let's all try that now and see if we could actually get Nova authenticate passing.
Is there any way you could not use a red font on the black background?
Not right now, no.
Any way of making it readable?
Yeah, let's do this.
Can you copy the code on the
Yeah, so I have it, if you click on this link over here, .github.io, and it's the slides at the bottom. So everything's there but the username and password for the VM we use, because I'm not going to put that up on GitHub. But everything else should be there. And sorry about the color choice.
It's just from this file, right? If Nova.authenticate doesn't throw an error, does it do it?
Yes, unfortunately, it doesn't have any crazy print statements in there. Unfortunately for our situation.
So what is get
It's internal right now, yeah. So we're actually not, it's inside the Nova object, the client itself, and that'll get passed in all around for you. So you can actually try is if you put in make something wrong in the parameters in the get Nova creds, and you put something in there, have a wrong username and password, you'll see an error. So here's the example of doing it wrong. So I have a typo in here, as you can see. So I have the wrong API key here, the password. And so this shows you what it looks like when it's wrong. So we try logging in, and we get an unauthorized error message. And then that's working. So one thing we actually do is we can run Python with the -i flag, so it jumps into the interpreter at the end. And so this actually gives us an interpreter with the Nova object initialized and have the client there. So you can see here some people have already started building some instances, and you can actually try this out and do different commands, like servers list or flavors list, etc. So has everybody gotten this working yet, or are we still working on it? I take that as a no. People are still busy. Okay. Any questions? Yes.
I have a virtual machine.
Mm-hmm.
And am I supposed Thank you. I have a virtual machine, and am I supposed to be able to SSH to it? I got the username and password there.
Yes. So for this VM, actually, there's SSH logging with the password is disabled for this system. So we have SSH keys only. Actually, to get the system for you guys to log into this VM, I had to go and change the SSH config. So the next step actually we'll get to is how to add a SSH key, create a new SSH key or add your own.
So the new system. But when I build a Nova.
Right. So you have to do it beforehand. So you. It uses the Amazon EC2 style SSH key system. So there's a cloud init script that runs inside the VM that'll pull down your SSH key. So the next step is loading the key pair in, and we'll get to that next. Yeah, so you could create an instance very easily that doesn't have any way to get into it. So is everybody ready for this or no? Okay. So now that we're into the system and we can actually see the flavors and images, we need to create a key pair we can get in. So this is actually the command if you're on your local system to add your local key pair in. So there's two ways of getting a key pair in the system. Either add your own key pair from your local system and SSH forward it in, or you could actually have Nova generate a key pair for you. So this is actually the code not to generate a key pair. This is to add your own, but I'll show you how to generate a key pair as well. So to use the system, we need the key pair. So we're going to list the key pairs existing. Let me see somebody, demo key, has already added his in. So the first step is if your key pair is not there, you want to create one. So you create a key pair, something like that. And now we see it's in the system. Then you can actually get the private key, which we'll need to use to log in with. And that's stored in the private key variable over here. So the other way of doing it here is you could actually upload your public key instead, and so that way the system won't actually have your private key in it. And there'll only your public key will be inside of Nova. So if you don't want to put your private key everywhere. And this will obviously not work on the VM unless you create a key pair for everybody, which we don't want to do. So you need to copy your public key into the system first or something like that. Any questions?
Want to delete the VM?
Delete. We'll get to that in a second. If you downloaded the slides, you can actually skip ahead if you want.
Does it use libvirt, or is it uses native KVM and Zen stuff?
It uses libvirt, although there's other backends that don't use libvirt. I'm not sure what this cloud uses, but I assume it's KVM and libvirt. Yeah. So there is backends for libvirt. There's LXC support in that. There's Hyper-V support outside of libvirt. Zen inside of, I think in and outside of, both inside and outside of libvirt. You name it, it's in there. IBM Z Systems is trying to get in there too, I think, right now.
Solaris? That aluminum.
Sorry, if you don't talk to MI people in there, it's one TVO. And
Okay.
people in streaming neither, so they only listen to him answering to you. So it's not so.
Sorry.
Okay, so I asked Open Solaris.
I am not sure if that one's there. Let me pull up the page that has all the...
Okay, I'll just check. I mean, it's not
There's an
too many
OpenStack
people.
wiki called wiki.openstack.org.
All
You
right.
probably can find it on there.
Okay, thanks.
So one of the things that people like about OpenStack, especially for deployers, is that there's many, many backends. And so if you have your own, you could choose whatever you want on the backend. So the API is all the same, but the backends are all very different. So it looks like we're mostly the way there here for the key pair, so we're going to go to the next step. So now we need to get the flavor object that we want to use. So you could list the flavors here, Nova flavors list, and then you could find the flavor you want, the M1 Tiny, or another flavor. Please use one that only has one virtual CPU and nothing more. So let's just stick with the M1 Tiny for this. So once we find our flavor, the next step is to pick an image. So the find command only works for exact images, unfortunately, where you could just pick it out of the list if you do a Nova images list and use just pick an index. So pick an image type.
In the flavors part, I got an exception that it doesn't know that M1 Tiny name.
It's just tiny.
It's just Tiny?
Just tiny. Remove the M1.
Okay.
So yeah, the names are by, it's just tiny. So all these names and images are all configurable, cloud dependent. So in this case, the cloud I put these exercises up on, or tested out, was a DevStack environment, which is a development all-in-one cloud you could use for building OpenStack and working on it that had M1 Tiny. So now we have the next two steps, and I'm going to go over them before we actually do them. So now we have our image and our flavor here, and now we want to get our instance. We want to boot that. And so this would be the command to boot your instance. We'll get back to this in a second. But once you boot it, the instance doesn't spin up right away. It takes a few minutes, up to, or more than that or less, depending on the system. So you can actually watch the status if you want. And so this is actually the code, and I'll go back to this in a minute, of how to actually track the status of the system. And also this is on the bottom here that'll print the addresses out that you need to log in with SSH. So it goes from you send the instance in, it'll go to building state, and hopefully it won't go to error state. And so if it works, it'll go to active, I believe, and at that point, it'll be up. So if you want to do this with the shell, then you could just keep trying and pressing, checking the status or whatever you want. Or you could actually try this out and write this and have it tell you when the system is up. So I'm going to go to here for a while and let me know when you want me to switch over to the other screen. And remember, we can only create 15 instances at a time, so if you get an error, it's because somebody else we're at our quota limit, and so we'll have to wait for somebody to destroy their instance.
So once it's booted, should it go to active? Status
Yes, that's correct.
It does that really quickly.
We're lucky. This is depends on the cloud, so some clouds will take longer than others, and it's very dependent on the system. But yeah, it's been, my use for this has been very fast. So thanks to Innovance for their great engineering work, whoever Shmuel is. So this is what we get. We'll show you when, if you guys are seeing this error, this is expected right now. So 15 out of 15 instances used. So we'll have to take turns on this one. So you see.
You can do like a length on this list.
Yeah. Yeah, sorry. So there we go, we're at 15. So for everybody who got their instance up before we hit the quota limit, you could actually take, so this is the IP address you'll need to get into the system. So before everybody got here, I went ahead and by default, there's EC2 style security groups. So by default, SSH is disabled into all these systems. So I went ahead and enabled ping and SSH to all these VMs. But on a regular system, you have to be aware that depending on the security group in the cloud, you may have security groups disabled or set to nothing by default. So you can see here, I hopefully can't log into the system because it's not using my key pair, I assume. But you can see the system is up. So the default IP we're all using here is a private IP for all these instances. So you can actually only get into them from this machine. There's a way, we're not going to talk about it today, but there is a way of adding a floating IP, a public IP to the system, but we're not going to do that today. Anybody have any questions, problems? Great. Once again, sorry for the problems here. We only expected 15 people, as that's the number I was told. So it's a few more than that. So it was an M1 small because I thought 15 people should be fine. So now that you have your separate instances, everybody should be logging into now, the 10 or 15 people who got lucky on this, you can go and do whatever you want on it. When you're done with that, this would be your instance on a real cloud. You can play with it, set it up, use Chef or Puppet or something else to deploy it. You could pre-build your own image and have your image be pre-built and not have to run Chef or Puppet on it. Or you could set it up, take a snapshot, and boot from the snapshot next time and things like that. When you're all done, get the instance object and just instance.delete, and that'll get rid of it. And it'll take a few seconds for that to happen, and that way somebody else could use the system. There's 15, so we only have 15 servers up, and there's more than 15 people here. So a bunch of people are.
So it is a reuse of the
right.
same resource.
Yeah, so the quota will go down, it'll decrease to 14. We'll see if one person deletes it, and there'll be one slot available that somebody else could use that.
The state of the system, does that remain the same, or it is
Of what system? Of the.
deleted?
So that'll actually destroy the VM.
Okay.
So it'll be gone. It'll get rid of the VM, yeah.
Yeah, and that's just the resources available, so anyone can create another one.
That's correct, yeah.
Okay.
Hey, Shmuel, what version of OpenStack is this? Let's say there's I recognize some bugs in this one. But, okay.
So we're not Rackspace or HP Cloud and people like that. You know, it's usually like demo cloud for people, but you can still like order. And it's using Folsom that we need to upgrade. And you have one in Paris that we upgraded to Grizzly. But yeah, the Paris one was too full. But yeah, if you want to try.
So this is the dashboard we can see. So the dashboard uses the same APIs everybody was using here, but it does it via a Django application that's running on site. So you can actually see what's going on with the system. And because they're all one system together, I could go ahead and delete them if I wanted to, but I'm going to be nice about it.
How can you monitor a process? How do you know if someone else is not going to create the instance?
Sorry, say that again?
So, for example, an administrator can delete an instance. Yeah?
Right.
Is there any notifications sent?
That'd be cloud specific. So that would be something part of like a billing system or something like that. And so that's outside the scope of Nova.
Is it? Okay.
So the way it works is Nova sends alerts to other systems when actions happen. And so other systems, like a billing system, could alert when an instance is destroyed. And they'll say, hey, wait a minute, an admin destroyed that. Maybe I should tell the user or something like that. But Nova doesn't have built-in email support. Yeah.
So it's not Nova scope at all?
No, it's outside the scope of Nova, but it is in the scope of OpenStack.
Do you guys have any question about Nova, by the way? He's the master of Nova, so he can explain it. He's the master of the universe. Joe, thank you.
Yeah, sorry.
So just if you wanted to just play more about with this more, how easy or difficult is it to set up your own test lab using Vagrant or any other
Right.
virtualization technology? If you just wanted to set up an entire lab type thing on your laptop and assume you have enough RAM.
Yeah, so there's actually there's something called DevStack. And there's a few ways of using it, but DevStack is a tool that we use every day it's used for developers like myself, and it's also used for the integration and CI systems in OpenStack use it. So every single commit to OpenStack is spun up in a DevStack environment and tested. And DevStack is all in one system, and it'll have all the Nova services, Keystone, Swift, Glance, Horizon, everything running in one system. And you could actually spin that up in Vagrant, or you could spin it up on a VM somewhere. And it's straightforward to use. You clone it, and you just run it, and that's it. So devstock.org, and it tells you the basics how to do it.
I'll try to show devstack after for the Swift one. Yeah, I just run on devstack the one we connect.
Any other questions? We have a few slots available. Somebody hasn't spun up a VM yet, so this says 10 right? Oh, it's 15. Never mind. If somebody wants to destroy their VM and let somebody else have a try, that would be appreciated.
They're taking a bit longer to build.
So that's expected. Part of this is actually a demo cloud by Innovance. So we can actually start seeing this is a fairly small cloud, is my understanding, which is why we're seeing a bit of a load on it.
What's the difference? There were two entries in a single row. Why was that?
There's two what?
Two IP addresses?
Right. So this is actually, so to get you guys to be able to log into the system from outside of Innovance's private network, I associated a floating IP to the server. And so this is the server we're all on right now. And so I did that, and let's take some of these random. So you would drop down and do associate floating IP from the dashboard. Or you could do things like create a snapshot. And then you can create a snapshot, and then you can boot from the snapshot later on. So you can see everybody's key pairs over here, just to show you more of the dashboard. We have our security group rules that we set up. So this is our floating IP that would be associated with this machine. And I could add more to the project, and then from there I could add it, you could add it to your server. And see, these are the two commands. So ping and SSH are enabled. For a real-world situation, you probably want to add more. If you're running a web server, you add port 80 to this, et cetera. And so by default, nothing's allowed. And so this is a big Django application called Horizon. Any questions? So this is the way to launch a VM from the dashboard. So image or snapshot. So if we took a snapshot, we could actually go ahead and build something off it. Boot from a snapshot. We don't have any right now. So you select the server type, name, et cetera. And then you select the key pair here. Yeah?
So once you boot in, can we programmatically, rather than log in, say a bootstrap chef?
Actually, funny you should mention that.
Okay.
So there's a, yeah. So this is how to do it from the dashboard, but there's other ways of accessing the system. But you could put in a script to run it right after it boots up. And so this uses the same Amazon-style system. So the same thing that pulls in your SSH key will pull in a bootstrapping script. So you could say, for example, I believe DevStack has an example on their website. So in the user data, they call it user data here, this is how you would do it inside of, so you could actually try this on a VM here. This is how you get DevStack running inside of a VM. And so this, you cut and paste this into that, the init script area. And so you just tell it to be a script, and then it runs, and et cetera. Any questions? So in addition to using this Python API, they could use the command line, so the CLI, typing in Nova space and commands. And there's also a bunch of third-party libraries that support, I think libcloud and a few others support. I don't know off the top of my head which ones do, but a bunch of them support OpenStack. So you can make something in a third-party library that supports OpenStack and EC2 or whatever else you want to use.
How do companies like HP and Rackspace benefit from this? I mean, you put a lot of money into it. And
Yeah.
how do you get it back?
The short answer is I'm not the right person to ask that question to. I'm a developer. The answer is that it's the same thing for open source. Why do people work in the Linux kernel? So it's the same sort of model there.
This isn't immediately obvious. I mean, Linux, yes, but for
Well,
this,
what's obvious about the Linux kernel?
they have to, well, a lot of supercomputers and whatever, and Android, and everyone is using it, and they're improving it because they're using it. And you're actually giving service to people to use OpenStack, but I don't see an immediate way to get
So there's a
money
few
out of
answers.
it.
Somebody's doing a public cloud. Shmuel, you want to answer this? Or
I can mention, yeah.
maybe you want to answer this one? You're a Rackspace, so.
I'm going to put my business hat, like I don't know anything about business, but I would say like it's what we call utility buildings. So that the cloud is the main thing of the cloud, like the way it works. Like the cloud is that a provider like Rackspace or HP Cloud or Imo us. It's like spin out a cloud, and you have like resources that can be shared. So you have like one machine, and people like spin out a cloud and cloud servers, and they'll be using it like only that part for a certain moment. And that's at a certain moment they're going to build, and they can spin up other VMs, other one. Making a cloud easy to spin up with an API, easy to think, encourage people like to try and to as well like spend more because they can have more ideas and do more stuff. So it's literally like what we call like infrastructure as a service. Being as a service encourage you to do a lot. So and the way the thing that it's all like virtualized, being the backend, and you can optimize your resources and do stuff, optimize your deployment. And it's not like the old way anymore. To answer your question?
Yes.
That was very businessy voice.
Want to add something? From Rackspace heads?
I just want to throw economies of scale into the mix. So like Rackspace operates data centers like 20 to 30 megawatt data centers. So we operate at a level of, sorry, do you hear me? Yeah, so we operate at a level of efficiency that. So we operate at a level of efficiency that allows us to turn a profit. So you come into our public cloud, you utilize all these resources because it's easier than operating all of this by yourself. We bill you, and the difference is still enough to turn a profit. That's the short answer.
Any other questions?
What is the easiest way to get into the instance once you have?
Yeah, so you'll need to copy the key onto the system, and so I shouldn't cover that. So you could use something Paramiko if you want to use it in Python. If you want to use something from the shell, you would SSH in. You have to copy your private key locally, and then you set it to, for SSH, you have to set the private key to 400 permissions, and you can log in. So SSH, if it's an Ubuntu system, it's -i my private key space Ubuntu at IP address.
What's the way to have the list of the instances that are currently running?
It's nova.servers.list. Let me show you that. What?
I'm surprised that you didn't crash here.
There's actually signature here.
Yeah, no.
It's the quote is broken. I don't think false on. Or
it
yeah.
Yeah, we need to be a bit quickly. I think we just finish the price one first.
It's actually working right now, but it went to like 17 at one point. We fixed that. And it's fixed in trunk. You couldn't. A lot of moving parts to it. And somebody deleted all the instances, it looks like. So I think we're done. Thank you. And if you don't believe me, so we're getting deleted, so we're going to have the Swift, I guess, now, or? All right.
Okay, so let's have a short break and then continue this. Do you do a Swift or start?
The way you guys want to get hammered by demos, or you want to take a break and have
Okay, so let's take a 10-minute break and then continue the brief intermezzo on cloud items.
How long is the break?
10 minutes. Is this enough? 10 minutes?
By yourself or with? No, I'm just fine. Daddy is around. Yeah. Oh, by himself also. I guess so. That's where he lives. So. He said, yeah, he's around. Hello. Did it walk? Huh? Yeah, I took days off and want to grab a coffee and come back?